Good morning, everyone. Today's lesson is 6.1, Graphing Systems of Equation. Starting a brand new year, I hope you all enjoyed your time off. I am in Arizona right now, and hopefully you can see the pretty mountains behind me. Let's get started with 6.1. Previous objective was to graph linear functions, and today's two objectives, we're going to determine the number of solutions a system of linear equations has, and then we are going to solve systems of linear equations by graphing. Now when we talk about systems of equations, what that means is we are going to start graphing two lines together and then classifying them on whether or not they are the same line, parallel lines, or perpendicular lines. These are some vocab words, and I'm not going to make you write down the definition of each one, but rather write down this concept summary of the possible solutions. So again, what's going to happen is you're going to be looking at two lines, and you are going to decide whether or not it has exactly one solution. And what does that mean? It means that it is consistent and independent. And that would be your answer that you write down when they ask you what type of graph it is. And as you can see, when they are consistent and independent, they are two lines that intersect at just one point. So the number of solutions would be where are the two graphs intersecting, and in this case they just intersect at one point. Infinite number of solutions means it's consistent and dependent. Think about it's dependent on the other. They are the exact same line. The reason why you're only seeing one blue line here is because the red line is the exact same. The third example would be no solution, and this is inconsistent. So a solution means that the graphs cross, and if they end up being parallel lines, which means that they have the same exact slope, they would not have any solution, and therefore their terminology means inconsistent. Alright, so hopefully you get these all down in your notes because it's going to help you so much when you start your assignment. So example number one, number of solutions. So you're going to use the graph to determine whether the system is consistent or inconsistent, and if it's independent or dependent. So looking at the graph, we can tell that they do not touch. So there would be no solution, and the system is inconsistent. So you're going to say whether or not it's consistent or inconsistent, and if it's independent or dependent. But as you saw in that last example, there are, if it has no solutions, it's just inconsistent. All right, so taking a look at the next graph, determine whether the system is consistent or inconsistent, and if it's independent or dependent. So they give you the two lines. It's x minus 3, which if I solved it, it would be this line right here. And then y equals negative x plus 1. So you're looking at these two lines right here. The graphs intersect at exactly one point, so there's exactly one solution. So that would be consistent and independent is what you would write down for your answer. All right, we are to the multiple choice question. Again, example one in your assignment is just going to simply look at graphs, look at the equations, and decide whether or not they intersect at one point, at all points, meaning they're the same line, or no solution. So the multiple choice question, I want you to take a look at these two equations. We have 2y plus 3x equals 6, and y equals x minus 1. So take a look at those two lines and tell me if they're consistent and independent, inconsistent, consistent and dependent, or cannot be determined. This is the Google question, multiple choice. We are going to go right into the open-ended question. So what I want you to do, same exact thing for example number one. I want you to take a look at example y equals x plus 4. And y equals x minus 1. Take a look at the two lines and tell me if they are consistent and inconsistent, and if they are independent or dependent. All right, example number 2 is to solve by graphing. So example number 1 was very nice where they gave us the actual graphs and we just had to look at them to determine whether or not they were had one solution, no solution, or all solutions. So now what they're going to do is they're not going to give you that graph. So they want you to graph the system of equation and then determine whether or not it is no solution, one solution, infinite solutions, and then if it does have a solution, is it inconsistent or consistent, is it dependent or independent? So as you can see here, you have two equations. The first equation, y equals 2x plus 3. This is in slope-intercept form, which is the proper form that we need to graph. So you're going to find your y-intercept, find your slope, and then graph your line. Notice for this second line, our equation is not in y equals mx plus b form. So we need to put it there into y equals mx plus b form and then graph. As you can see, when you graph that, or when you solve it for y equals mx plus b, you're going to get the exact same thing, y equals 2x plus 3. And what that means is that they are actually the exact same line. So there are infinite number of solutions, meaning that those lines will be the exact same and they go on forever and ever. All right, so same exact thing. We have two equations. They are not in y equals mx plus b form. So step number 1 is to put them in y equals mx plus b form. By doing that, when you graph them, they are actually going to be parallel lines. So when you look at the parallel lines, you need to decide that because they are parallel lines, they do not intersect and there are no solutions. All right, here's a checkpoint if you want to pause the video and try one on your own. Same exact thing. There's only 2 examples in this lesson. It's identifying by looking at the graphs, and then step number 2 is actually graphing them to identify whether or not how many solutions that they have. All right, when you graph these two, they intersect at one point. What they want you to do, your solution would be that one point where they intersect. It's one solution, it's consistent and independent, and they actually intersect at 0, 3. All right, that is it for today's lesson. It's very quick. Again, example number 1, you're looking at equations and you are going to decide whether or not they are no solution, all solution, or one solution. And then example number 2, you are actually going to graph and decide how many solutions that they have by looking at your own graphs. That's it for today. I will see you tomorrow for the next lesson.